Okay, to let you understand this segment, I'm going to start with small examples first. We will advance to the harder topics later on. Can we write down what are these numbers if we try to substitute the different n values? So when n is 1, let's write in the number. This x1 is actually the value 1. It's a straightforward example. Your x2 is the value half. Your x3 will be the number 1/3. Okay, but what we would like to further see is, can we represent this onto a graph so that we relate to a graph situation? In my axis, help me label in, I would like to have n versus xn at the top. We are going to put the different n values, such as n is 1, 2, 3, 4, and so on. But let's just plot out maybe for 4 points. For the vertical axis, we want to do something similar. So your highest value, I'm going to put it a bit out of scale so that it's easier for us to draw. So when your xn is 1, this is happening because your 1 gives you the value 1. This is our x1. So my next number is at half. This is occurring for the number at 2. And then you have 1/3. And so on. We keep going lower and lower and lower. Now let's say we were to continue plotting. Then we know that these points are going lower and lower, closer towards the horizontal axis. If I would like to label, this is labeled as a sequence of numbers that is xn is equals to 1 of n. But to understand this word called the limit, we will have to think from the perspective of if there is a graph. I'm going to have in red so that you can see that there's a difference I'm going to draw out. Let's have y against x axis. But in this particular situation, I would like to have it like a graph of y equals to 1 of x. Let's say I want to draw this graph inside. How does the 1 of x graph look like? Can I put it in dotted and you make it pass through all your points? It's actually the same graph, just that one of them are drawn as points. The other one is a continuous graph throughout. That is your 1 over x graph. Why is it that we want to relate? For a 1 over x graph, my graph goes very, very close to the horizontal axis. What is that called? We will say that y equals to 0 is an asymptote. We knew about asymptotes from the graph perspective. So today we are going to look at a change if it's a sequence of numbers that is xn. What is the same concept by trying to know that the sequence will go close to the horizontal axis? It will go close to 0, but it will never touch. The same word for that for a sequence of numbers is we say 0 is the limit of the sequence. You can think of the word limit and asymptote as a similar concept, just that one is for graph, one is for sequence of numbers. So therefore, we want to learn how to write it out in words and also mathematically. When n is large, what can we say about xn? I can say that xn tends to, or we can use the word converges to 0. Tends to or converges to 0. There are two ways that we can write this mathematically. Even later in the solutions, I will show you different ways of presentation. Number one is we can say as n tends to infinity. I can mention that my sequence xn tends to 0. Okay, so just to let you know, the arrow is read as tends to. The other notation is to specifically write out the word limit, but limit in short, in terms of notation, we just write as lim. So we say limit of xn as n tends to infinity is 0. There will be a confusion as you solve problems later on the notation. Just be careful. The first line is arrow to 0. the second line is equal to 0, it's not the same. And that's because on the second line, let's try to write down how we read this statement. This is read as limit of xn as n tends to infinity. The reason why we write equals to 0 is because we say the limit is 0. Is means equal. That's why the second line is presented with an equality. In general, this is what's going to happen. If I have n tends to infinity, your xn tends to s, then we say that s is called the limit of your sequence. We can also use the phrase, your sequence is convergent to S. And we can then say limit of xn is S. So I've explained this with the example above. I now want to show you what are the two main types of sequence that we need to know. Number one is, you want to know what happens when your denominator has n. Okay, that is for the top cell. And let me just write in below first before I explain. The second type is n is in the power. There are just these two main types of sequences that we want to know what happens to it when n is large. So what will happen to my terms? We have seen the first one, if n is in the denominator, it doesn't matter that there is a constant or a coefficient. The concept is that you will end up with 1 over a very large number, which is always about 0, as long as n is in the denominator. So both cases will give you that 0. In terms of presentation, there are also two ways to write. What I have printed for you is the first way. We know that the second notation looks something like that. You can also say when n tends to infinity, your 1 over n will tend to 0. And both are okay in terms of presentation. Okay, you just absorb the properties first. Don't need to memorize anything. Later, when we go to the questions, I will guide you further. Okay, so second one again, if n is in the power, a power n will become 0. Let's try to visualize a little bit right on the right-hand side. What happens when n is 1? When n is 1, your term is 1/3. When n is 2, your term becomes 1/9. When n is 3, it becomes 1 over 27. So your values get smaller and smaller. It will tend to 0. As long as the value in the base is a number smaller than 1, your value will get smaller and smaller and will tend to 0. Then there is a second way to present the same thing. We use the n tends to infinity notation. I can also say as n tends to infinity, your a to the power of n tends to 0. Okay, so both are okay in terms of the presentation. So what are we looking out for? I am looking out for whether the denominator has n, or if you have a power, look at the base value, you want the modulus to be something smaller than 1. If that happens, it's also 0. So on the flip side, if b is a number larger than 1, such as, let's go for example first, 3 power n will surely tend to infinity. If you tend to infinity, we will say that the sequence no longer is converging, so we use the word diverge. Diverge means the opposite. Okay, in exams, it's rare to say something diverges, but this is one of such situations. So when it diverges, you can only present in this one way. The following is wrong. It is not okay for you to say the limit of n for Bn equals infinity. There is no such thing as limit is infinity. All limits must be a constant. So that we will say the sequence converges to a constant. You can never say converges to infinity, no such thing. Infinity means diverge.